First, before I introduce all this detail, let me show you how does the Stellar software look like. Well, I like Stellar because it's easy to use. Well, Stellar has 4 layers of artifacts, or say the design has 4 layers. The interface basically give the user some input variables, also give the user some kind of output, like a graph you want to draw, or some table, and you want to see the content. The input could be, let me see, okay, some bar like this. You only need to drag. And now, if I put some number, I need a name. So you can drag this bar and make it bigger or small. Or you can make any kind of like a switch, like you can turn around, big and small, like your radio control. That's the interface. Basically, it talks about the input and the output in this layer. Next, we have so-called a map. The map is what I call conceptual model. I call it as a conceptual model. Conceptual model. It describes the qualitative relationship, no quantitative yet. So I say, hey, I have a fluid mixing problem. I have one tank here and another tank here, and these 2 tanks exchange the liquid, and this is going out. Maybe this is where they flow in. It might have something flow backward. That's kind of thing I call it a conceptual model. There's no quantity is involved in. Well, the next level, we call it a model. See the question marks here? That is the time we have to put the equations, like a differential equation, algebraic equation. We usually put it here. And the last level is the equations. It automatically produces the relationship flow in and the flow out. Let me erase that. Well, I said that I'm not going to go through the tutorial. I only introduce the idea. But if you go to the model level or the map level, you see it's very clean and simple. Not many things here. You only see 1, 2, 3, 4, 5. Well, I'm not going to talk much about the 5th. But you have already seen the 2 of them. That one is what we call it the stock. And if you map to the example I gave a moment ago, that stock is really the cup here. That's a stock to hold the water, the material flow. Okay? And remember these two flows. And the pipes, of course, that's the flow. And we call it a flow controller. The next, you have this. What that is? That's the pipe, right? And then, of course, this we call it flow. That's the thing describe what you probably have seen when I ask you the questions. But that's not the whole thing. This is the second flow. I don't use the name flow now. This thing is the information. That looks like my eye. That will be called the convert. The convert. And then there's another one here. I can put it to here. It depends what you need to do your calculation. That's enough probably. That we call it a connector. What does these two red lines represent? Back into the example I gave to you here. Those lines represent the information flow. Now the convert is like my eye, my brain. I watch this water is full, and then the information sent to my hand. I turn it off. And so look at this switch here, and compare this switch here. That's where you really control. So 4 is good enough. This, be honest with you, is the most simplest model tool I have seen before. And you can think of this stellar as a tiny piece of the Simulink. You know, in MATLAB, I have this Simulink. Well, Simulink is great if you do engineer work, but the learning curve is too big for the teacher to use it in the class, especially for the mathematics class. So Stellar is a good choice for us to learn the idea. Now, probably you say, oh, it's not too bad, but you may not remember all those things. Let me go back into the slides and show you the 4 elements you have to know. The first, stock, that's the cup. And then second, the flow, represent the action, the change of the quantity. The third, converter, represent the logical parameter or information. And the last one is the connector. It really represents the information flow. 4, that's it. For any model, then you can run it. I'm not saying 4 is good enough for all the representation, but the 4 elements here captured all relationship. The only complexity just comes from how many variables you have. Each variable you have 1 stock. And if you have all the stock, you have all the flows. And how complicated is your formula here? We need to specify. Let me do a little example. The first example is an integral. You all know how to do integral. And this you learned in Part2, depends on what is your function. But the stellar never really do integral. They only do numerical analysis. So let me run this example quickly. So in this example, we are going to integrate the cosine function. So I need this. I call it as y. And this, I will call it f, the function. And then I need some information. I call it x. And the x help me to do the calculation. So that's my model. The model I try to build is really y equals cosine x dx. Maybe I will call it cosine t. T goes from 0 to x. And of course, that's too simple. You know the idea is sine x. But the conceptually, that's all you need. And the y needed the information f. And then in the conceptual level, it's just the ft dt. Now, if I click the model, you have all the question mark. So first, what's your y in the beginning? Of course, y is a function. You do not know everything, but you must know what is in the beginning. That I call it the initial condition. Now, once I put 0, that's gone. And you check it, you're good. Well, you need to put a unit later on, but I'm not going to go through this right now. You can say it's time, okay, it's time, per hour, whatever you want. And what's the x? Well, the x is the time, right? T. Okay, x is time t. You always have those functions, and the implicit variable is always the time t. Now, what's f? Well, the f is a function of x. Oops. But what a function? It's up to you what you want to do. I like to do the cosine function. Then you find the cosine here, and then you click x. That's it. Then it's cosine x. Now I've answered all those questions. I get the mathematics model in the graphic representation. And the last layer, look, I have an equation. And that does not look like a differential equation, but it more look like a difference equation. The y right now equals the y a moment ago. That minus dt means a moment ago. And the plus this f, which is the right hand, times, that's the f, dt. So if you make it this, just rewrite a little bit, divided by dt equal ft. You know, the only thing we missed as a differential equation is we need to let the dt equal 0, go to 0, not equal 0. Well, it's your choice for the dt, but the smaller, the better. So if you let this go to 0, in the calculus, we know if this go to 0, you really get the y prime t equal ft, and then yt equal ft dt, and that's the fundamental theorem.